The channel, and in this video we are going to talk about the Kubernetes interview questions part 2. So this video will consist of 10 questions, and these questions are related to the Kubernetes only. So we are going to discuss all these questions within 10 minutes one by one. So let's get started with those. First question comes as, what are core component of K8? So as you can see, I have also, already written the answer as well, because in the last video someone asked in the comment section only that it's good to have the questions, but it will be more helpful if you provide the answers as well in the written format rather than just explaining only. So I have written down the answers as well and questions as well now. So Kubernetes consists of the following core components. It is divided in the two parts: control plane, or you can say the master node components, which has the four components. As you can see, the Kube API server, main API gateway for the cluster. Like through this API server only you will be able to communicate with your cluster, correct? Then the etcd, which stores the state of the cluster. You can say a distributed key value store that holds the cluster state and configuration. Whatever the configuration you have made within the cluster, all the configuration and the state of the different jobs, the different config maps, the different configuration, all the things are stored in the etcd in the key value pair. Third component out of the master node component is kube scheduler, which assigns pods to run need. Like one pod is there which needs 1 GB of memory, correct? 1 GB of memory and some of the storage. So based on the requirement of the pod, it will kube scheduler will decide on which node it will get scheduled, correct? So that's the job of the kube scheduler. Then controller manager, which manage the controllers like replication controller, correct? So how many number of pods should get running, correct, according to the particular deployment. So that will be managed by the controller manager. If anytime anything goes down, the controller manager will check for the desired state and it will replicate the new pod coming up, and same goes for other controllers as well. The other component out of the worker node components are kubelet and kubeproxy. Kubelet is responsible for it ensures that the pods are running as expected. That means your pod is healthy and it's running, correct? Then kubeproxy is there, which handles the networking between the different pods, between the different services within the cluster. You can say handle networking and route traffic between services. So these are the two you can say the component: control plane, worker node components. And within the master node or the control plane, there are four components: kube API server, etcd, kube scheduler, controller manager. Then within the worker node, there is a kubelet and kubeproxy. So you can answer in this way: what are the core components of Gate? This is the architecture, you can say. Then next question is, oh, I just missed. The next question is, what is a pod in Kubernetes? A pod is the smallest deployment unit in Kubernetes. So when you talk about the K8, correct? Deployment file, daemon set file, stateful set file, config map, secret. Pod is the smallest deployable unit in Kubernetes, which runs your different containers, the different processes within it, correct? It represents one or more container running in shared environment. So one pod can run either one container or the multiple containers, 2, 3, 4, 5, how many number of containers you want to run, you can run. Containers inside a pod share networking and storage resources. So if a particular pod has 10 GB of storage, so the different containers can consume the different kind of storage. So you can define the different storage for the different containers. When we say the containers, that means your application, correct? How can you write YML file for your pod? That is over here, API version v1 kind pod metadata specification. So this one you can see, correct? So this is how you can write the YML file for your pod. Then moving forward, what is the purpose of kubectl or kubectl, you can say? Kubectl is the primary CLI tool for managing Kubernetes resource and interacting with the cluster. Here are a few kubectl commands you should be familiar with. So if you see in the first part we talked about Kube API server, correct? Main API gateway for the cluster. So you can communicate with your cluster with the help of kubectl command, or you can go with the K8 API calls as well. So this is one of the way kubectl through the kubectl commands you can interact with your cluster. So that's the purpose of kubectl. It's the primary CLI tool for managing Kubernetes resources. Moving forward, if you see the kubectl related commands, these are the basic example commands: kubectl get pods, kubectl get services. It lists the all pods, list all services, view logs of a pod. So these are the commands of the kubectl through which you can interact with your cluster. You can list down the services, you can do the modification, you can change anything, correct? Fourth question, what is a deployment in Kubernetes? A deployment in a Kubernetes is a higher level abstraction that manages the life cycle of pods. So we talked about the pods, that it is the smallest unit which is deployable in the Kubernetes, which runs your the different containers, correct? Deployment is nothing but it's a higher level abstraction of the pods only, correct? How pods will be managed, how much resources will be there, how many number of replicas will run for the particular deployment. So it ensures that the desired number of replicas are up and running and provides feature like rolling update, rollbacks, and self-healing. These are the features of the deployment. If you want to see the YML file for the deployment, this is the YML file, API version app/b1 kind deployment. In the deployment, kind is deployment. And then metadata specification, and all these are the configuration related things which you should practice while appearing for the interview, correct? Interviewer might ask you to write down a simple YML file for the deployment, for the daemon sheet, for the pods, anything, correct? So you should be aware of this as well. Moving forward, question number 5. Sorry, where is the 5? What is the deployment? What is a Kubernetes service and why is it needed? A service in Kubernetes exposes a group of pods and allow communication between and to them. So it's a service is a kind of like there are multiple types of service. We will be taking that question as well in the next one. But there are multiple services. If you have deployed your application and you want it to expose to the external world, you can expose through the help of service. If you want to make the communication between one microservice to the different microservice, you can create service and you can enable the communication between the different pods. So as you can see the definition as well, a service in Kubernetes exposes a group of pods and allow communication between and to them, correct? So pods can communicate with each other. When we say the pods can communicate, that means processes running in the different pods can communicate with each other. That means if there is one application and that has to get the data from some other application which is running within the same cluster, they both the services can communicate with each other even though they are running on the different pods, because we have enabled the services, correct? Which kind of services you can enable for internal communication and for the external communication, that we will be talking in the next question. Since pods are ephemeral, their IPs can change, meaning the application talking to the pods must also change the IP address. Services has the stable IP addresses, therefore provide a stable network endpoint with a fixed IP addresses, correct? That's why there is a service concept in the Kubernetes. Your pods are ephemeral, correct? So anytime if it faces any error, it will get restarted, the IP address will get changed. So if your application A is communicating with application B with the IP address 1.0 and the application B get down, now it has come up with 2.0 IP address, correct? Just for example. So your application A does not know that 1.0 is there or 2.0 is there. So service will be there which will route it back to the same application B, correct? Even though it's 1.0, 2.0, 3.0. So service gives a stable IP address so that you can make the communication between the different processes. Moving forward, if you want to see how service file can be written, it's the kind service, metadata, specification, selector. If you see, based on the selector, it will route there, correct? And which kind of services you can create? Cluster IP for the internal communication, correct? If you see, the IWAP service forwards traffic to the pods that have the label app my app. So it goes with the labels. The application which will have this particular label my app, the service will route the traffic there. So question number 6, what are different types of services available in Kubernetes? We talked about the services. So what are the different services? So there is I move to the next question. Let me come back. Cluster IP, node port, load balancer, external name. Cluster IP is the default one which allows for internal communication of the pods only accessible from within the cluster. Node port, this exposes the service on a static port of each node. So just suppose that your cluster has 5 number of nodes which are running. Like you have launched a node group and that node group has 5 number of servers running. That means the 5 number of EC2 instances if we talk about the AWS cloud. So with any of the public IP address of your EC2 instance, you can access this particular application which is running. Correct? It exposes the service on a static port of each node. So each node will have particular IP address, correct? With the IP address of that, you can hit the static port like on which your container is running, target port, and then a static port of each node, making it accessible from outside the cluster. So even though you are outside the cluster, you can hit the IP address and the static port, you will be able to see the application which is running. Then load balancer, uses a cloud provider external load balancer. Like if you are deploying it on the AWS side, it will launch a load balancer, AWS load balancer, and with the help of that load balancer, you can access your application which is running within the cluster, correct? Then accessible via public IP. The service is then accessible via public IP. External name is kind of mapping to the DNS. Like I do have a customer DNS called as ecommerce.com, abc.com. That can be mapped with the direct IP address of the node on which my application is running. The service is then accessible via public IP, correct? So sorry, the maps a Kubernetes service to an external host name. So the abc.com can be mapped with your IP address on which your application is running. So that's the external name. Moving forward, the question number 7. What is the role of config map and secret in K8? Config map stores non-sensitive configuration data while secrets stores sensitive data like API key and password, certificate related details like your certificate TLS private key, TLS your certificate data. All those things can be stored. The any database endpoint, database passwords that can be stored over here. The API related tokens that can be stored in the secrets. While config maps stores the different kind of environment variables, like you have to use the DB name, you have to use the DB host that can be done publicly. You can use the labels, you can use the variables like which environment you want to deploy, production, staging, test, QA, whatever the correct. So non-sensitive data can be stored in the config map, while the sensitive information can be stored in the secrets. Using secrets allow you to avoid putting secret information into your application code. In contrast, config maps will enable you to make your application more configurable. So with the help of config map, you don't need to put all the environment variables value in your code. You can create a config map value and you can refer that while doing the deployment. So it will fetch the value at the dynamically, and it will pass all the environment variables value to run your application, correct? So that's the use of config map and secrets. You can read about this. Let's move forward for the YML file of the config map and the secrets. So this is the YML file for the config map, kind config map, metadata and data, database URL here you can pass. While in the secrets, API version v1 kind secret, you should focus on the API version as well, correct? If you see API version v1 for the config map, for the secret, while it was app/v1 for the deployment. So you should focus on these things as well and the different syntax of this. While creating secrets, you need to pass the type, opaque or the TLS, whatever the you want to create the secret, data, password. Moving to the next question, what are the question number 8? What are namespaces in Kubernetes? A namespace is a virtual cluster within a Kubernetes cluster, or you can say the segregation of the resources within the clusters. Like within one particular area, you have just created section A and section B, and then you are creating the different resources in section A and the different resources in the section B. So it's just a virtual cluster, you can say, or the segregation of the resources. It helps to organize workloads in multi-tenant networks by isolating resources within a cluster. You can find a shortcode snippet that shows how to create a namespace. So this is the command you can use to create namespace. kubectl create namespace dev, and it will create a namespace called as a dev, correct? Then moving forward, you can create the pod within that particular namespace. kubectl run nginx, you can run the nginx, and image you can use the nginx namespace dev. So within the dev namespace, this will run. It will not run throughout the cluster. It will not run in the different namespaces other than the dev, correct? But it will run within the dev namespace only. This nginx server will run. Then question number 9. What are the labels and selectors in Kubernetes? Labels are key value pairs attached to objects. Example, pods. They help to organize Kubernetes objects. Like you have 100 numbers of items, and out of 100 numbers item, you want to rate someone as a good, someone as a bad, someone as a green, someone as a yellow, different colors. So the different colors are kind of labels and selectors. How will you select, correct? So that's the way. Here is an example pod that has the label environment production and app nginx. So if you see, this pod has labels environment equal to production, app equal to nginx. Now you could use the following label selector to fetch all pods that have the label environment pod. So like you just get into the namespace dev, and within this namespace dev, you want that all pods should get listed which has the labels as production or the dev, correct? So you can run this command. Which command? This one. kubectl get pods namespace dev, and all the pods which has the label called as your dev, that will be listed over here, correct? Where I went, okay, yeah. So that can be listed. Now moving forward, what are the persistent volume and persistent volume claim, PV and PVC? That is the short term which is called eventual. So let's get into the definition over here. Persistent volume provide storage that persists beyond pod life cycle. So as we talked about, pod is ephemeral, correct? It can be restarted anytime due to certain issues. Here it can get in the crash loop state, it can fail, it cannot be available, your its IP address will change, the data can be lost, correct? So you have the concept of storage in the Kubernetes where persistent volume provide a storage that persists beyond pod life cycle. That means even though your pod goes down, your pod get destroyed, the persistent volume will be there, which will store all the data which has been written there while the application was running on that particular pod. How it will be done? So for that there is a PVC. So for every pod there will be PVC. It can be attached to one or multiple. That mapping is on yours. The PV is a storage piece in the cluster. PV exists in the cluster only, correct? It's on the cluster level. That's the interview tricky question. Someone can ask you that where does PV exist? So PV exists on cluster level, not on the namespace level, correct? That has been provisioned by a cluster administrator or dynamically provisioned using storage class. A persistent volume claim is a request for storage by a user. That means if there are 10 number of pods running, they all 10 pods can request from the PV that I need some amount of storage, and then your PVC will be created. Here is an example, PV and PVC YML definition. So if you see for the PV persistent volume, it is persistent volume, that's the kind. It has the specification as storage 1G and access mode read write once. That means data can be either read and write, both the things, correct? If you see the persistent volume claim, it has the specification access mode read write once. That means the data can be read over here, it can be write over here, and it has requested the storage 1G. So if the 10 number of pods are there and it has the persistent volume has 10 GB, so each 10 pods can request for 1 GB, 1 GB or 2 GB, or how, like, it all depends on how you want to distribute, correct? So that's the way you can use. So persistent volume stands on the cluster level, while PVC stands persistent volume claim stands on the pod level. It can request from the PV that how much storage it requires or how much configuration it requires to store the data. So this is all 10 questions I wanted to talk about in this particular video, and it's explained with the answers written. I hope it will help you to get started with the interview preparation for the DevOps or for the cloud engineer, for the platform engineer. So watch out the videos and subscribe to the channel to get more technical contents related to the interview preparation, related to your technical stuffs like AWS, Terraform, GitHub Actions, Jenkins, and other DevOps skill set. So subscribe to the channel. Till the time, thank you. Bye bye.